Hello and welcome back to our second lecture video discussion on chapter 2. In our first video discussion, we learned how to summarize data for qualitative variables using the frequency, the relative frequency, and the percent frequency distribution table. We were able to summarize raw data into a more presentable table form. And then we learned how we could use bar graph, pie chart, and dot plot to actually visualize our summarized data. In this video, which is section 2.2, we are going to look at how we could summarize data for quantitative variables. So just like we did for categorical variables, we can first of all develop frequency table distribution for our quantitative variables using a step-by-step approach, and then we can summarize them visually using histogram or a stem plot. So that is the main goal for this section. We're going to summarize the quantitative variables, the numbers, using a table, and then we will transfer our summary on the table into a graphical form. Let's start our discussion with the step-by-step approach for creating the frequency distribution table. Now, because in this case, we are looking at numbers and not just different values for the categories, the first thing we're going to do is we will try and find, using step-by-step approach, the number of non-overlapping classes. And don't worry about that. I'll show you how we will do this with an example. And so first we will choose the number of ranges that will be used to group the data. Then we will identify the width for each class. And then after that, the third and the last step will be to determine the class width and then fill the mean with the values that goes into each class. So let's start with a very simple motivating example. In an accounting firm, they have a number of days they use to audit a company. Here in this raw form is a number of days that were accounted for the year-end audit times. So in some cases, they use 12 days, 15 days, 20 days, 22 days, 14 days, another 14 days, 15 days, and then 27 days. So the year-end audit times that were recorded for the organization is what you see here. Again, in their raw state, it's a bit difficult to understand. It's not presentable. We are not able to clearly represent this. But using tables and histogram, we can represent this in a more presentable format. Now, understand that the variable that we're looking at here is the year-end audit times. This variable is quantitative, right? Why? Because it takes values that we could perform arithmetic operations on. We can add, subtract, multiply, and divide the values in this quantitative variables. So the best way to represent or visualize this quantitative variable values is to use a histogram or a stem plot. Let's look at how, or the step-by-step approach to creating a histogram for this. So the first thing is we choose the number of classes. Now, this is an arbitrary number. It can be any number, but we strongly advise that when you have a small data set like what you have here, it's easier to just use the number 5. And so for this course, I will always encourage you to use 5 as your data set. So your first assignment will require you to follow this process. Always use the number 5 as the number of classes, and that's the first thing we do in this three-step process. We choose the number of classes, which should be 5. Now, the next thing we're gonna do is to find for each class how big it should be, the class width. Now, to calculate the class width, we're just gonna go back to our data set here, and the formula for finding your class width should be equal to the highest number or the maximum number in your data set minus the the minimum number in your data set divided by number of classes. And so in our example here, I want you to look at the data set. Tell me which one has the maximum number. From our data set, we will all agree that 33 is the highest number and that is our maximum. So it's 33 minus which one is the minimum number in our data set. Is it 13? No, it is 12. So the minimum number is 12. So it's 33 minus 12 divided by how many classes are we looking at. Again, because this is a small data set, we are using a small number of classes, so the number of classes is 5. Now I'm sure somebody is still asking, why is it 5? Again, because the data set is small, I always encourage that you use 5. Actually, I will require you to use 5 on your assignment. If you use more than 5 number of classes on the first assignment, you are definitely going to get a deduction on that. So 5 should be the number of classes. Very important for your first assignment. So we calculate the class width. When we subtract 12 from 33, we are looking at what? Looking at 21. We divided 21 by 5, and that should be equal to 4.2. This is the width for the class. But to determine the width for each class, we don't want it to be a decimal value. And so we will run it to the nearest whole number, which is 4. And so each class will have a size of 4. We'll go on to the next part of our step 2 process. And for each class, we're going to start from the lowest number, which is 12. 12 plus 4, which is the class width, will give us 16. And so for this class, we are moving from 12 to 16. Now we do the same thing here. After 16, we go on to the next batch, which is 17. 17 plus the 4, we're looking at 21. So the next class will range from 17 to 21. Then we do the same for the third one. We go on to the next number, which is 22. We will add 4 to that, going back to our class width, 4, and that will be what, 26. So our next class will start from 22 to 26. And then we'll do the same for all the others. We're going to start from 27 to 31, and then here from 32 to 36. Now, we are almost there. This is the last step in our frequency distribution table creation. Now, what we're going to do is we're going to go back to our raw data set and we're going to look at how many numbers are between the numbers 12 and 16. So going back to our data set, we're looking at how many numbers, the count of numbers between 12 and 16. And so we have 1, we got 2, we got 3, we got 4, we got 5. Remember, we're looking between 12 and 16. We have 6, we got 7. And so we have 1, 2, 3, 4, 5, 6, 7. The count of numbers between 12 and 16 is 7. And that is the frequency for that class. Now let's go on to the next class and count the numbers between 17 and 21. So I'm going to use a different color here, just so I don't get messed up with my colors. So 17 and 21, we have 1, we got 2, we got 3, we got 4, we have 5, we got 6, I almost missed it, and then we got 7. So between 17 and 21, the frequency count for that class is 7. Now I want you to pause the video and then look at the table again and tell me how many are between the next one, 22 and 26. Did you get 3? And And that is exactly correct. And so we do the exact same count or frequency count for all these classes. Now, it's important to know that when you add up your frequencies, they should be equal to 20, which is the exact same number of observed data here. When you count this single data, or if you count this data set, it should be equal to 20. Now, once we have the different classes and their frequency distribution, our next step will be to create the relative frequency distribution. Just like we did in the case of categorical variables, frequency distribution calculation will be the frequency for each class divided by the total. And that will give us our relative frequency. And so for the class of 12 to 16, we will divide the 7 by 20, and that should give us a relative frequency of 0.35. We do the exact same thing here. We divide the frequency of 7 by the total of 20. It gives us the relative frequency. And so we calculate relative frequency for each class. Again, this is to tell us the proportion or the relative portion for each of these classes. The first class had 7 out of 20, so the relative frequency was 0.35. Second class had another 7 out of 20 for a relative frequency of 0.35. The third has 3 out of 20 for a relative frequency of 0.15. And then for the fourth class, we have 2 out of 20 for a relative frequency of 0.1. And then the same for the last 1 out of 20 for a relative frequency of 0.05. Now, when you add up these relative frequencies, it should be equal to 1.0. Be careful. When you add up your relative frequency and it's not equal to 1.0, it means you are making a mistake somewhere. We calculate our percent frequencies by multiplying these relative frequencies by 100. So we will convert the relative proportion for each class into their percentage equivalent by multiplying by 100. Now, in the same way you should expect 1.0 for the relative frequency, your percent frequency should be equal to 100. So you add up these percentage values here, and if they are not equal to 100, it means you have made a mistake somewhere. Now, there's the other portion of finding cumulative frequencies, where we look at less than or the portions less than the maximum value for each class. And so to do that, we basically just add up the numbers or the frequencies to the previous one. So we start with a 7, add up the next 7 to this 7 to get 14, add the next 3 to this 7 to get 17, and then it follows in the same vein or in the same direction. But cumulative frequencies is a little beyond the scope here, and so not super important. Now I want you to pause the video and I want you to create a frequency distribution table for this quantitative variable. The question says, a startup company's ability to gain funding is a key to success. So here we're looking at a very small startup company trying to gain funding for its job. The funds raised in millions of dollars on March 10, 2011 by 50 startup companies appear below. And so here we're looking at 50 different companies and how much they raised. Some raised $81 million, some raised $80 million, some raised $69 million. I want you to spend some time and create a frequency distribution table. Don't focus too much on the cumulative relative frequencies, but I want you to look at the relative and the percent frequencies. Using a frequency distribution table, let's create for 5 classes. Create the class size, find the frequencies that goes into them, and I want you to calculate the relative and the percentage frequency. So pause the video and then do that. Welcome back. How did it go with your relative and percentage frequency distribution table for the quantitative variable? Now, once we're able to create the table, the next step is to create a histogram. Now, a histogram is the most common graphical display for quantitative variables. Of course, we have stem plot and we have other ways of visually representing our quantitative variable values, but over the years, a histogram has been accepted as the most common graphical way to display our quantitative variables. First, we need to summarize the data, and then we need to describe it in terms of the shape, the center, and the spread. Now, in this video, I'm going to show you how to describe a histogram based on the shape. In chapter 3, we will look at describing our distribution in terms of the center and the spread. But for this section here, our main focus is going to be on the shape. Once we have our frequency distribution table created, using the relative frequency or the percent frequencies for each of the sizes, we could create a histogram. So in our previous example, remember we were starting from 12 to 16 as the first size, and then we have 17 to 21 as the second size, and then we have 22 to 26 as the third. Now, using the frequency of count or the percent frequencies, we could create different bars to represent how many were in each sizes, right? We could create different bars to do that. And that's what a histogram gives us. Now, know for a fact that bar graph is for qualitative variables, histogram is for quantitative variables. Another distinct difference you will see between a bar graph and a histogram is that a bar graph has distinct bars. For a histogram, because we are dealing with numbers, the bars are super close to each other. I didn't do a good job here, and so forgive me for that. But the bars for a histogram are clearly different for the bars from a graph, for a bar graph. Now, the big question is, how do you describe in terms of the shape? When you look at the shape of a histogram, we are looking at two ways to describe it: the mode and the pattern. Now, how do you describe the mode? The mode basically refers to the number of peaks in your histogram. How many peaks do we have? Now, somebody will say, what is a peak? So as I look at this histogram, for example, the peak is the topmost level. So in this case, I only have one peak. I go up one time and I come down, and so this is just a single peak here. And for that, this histogram, in terms of the mode, is unimodal. Uni basically means there's one peak, and then the modal here means we're looking at a single mode. So unimodal, one mode. Now, take a look at another example here. Maybe I should just create a simple example here. If I have a histogram of this format, take a look at this one here. Now, in this simple example here, I have a first peak, it falls down, I got a single peak, and then it falls down. It's not about how high it is, it's about the fact that we came down and then we went up again. And so in this histogram here, I have the first peak and the second peak. Because there are two peaks, okay, forget about the height. It's not about the height, it's about the fact that we have a high, a low, and another high. Because I have these two peaks here, this histogram is considered to be bimodal. Bimodal because we have two peaks. Histogram with more than two peaks are called multimodal. And that is how we describe histogram. Now, the other way we describe the shape of the histogram is in terms of the pattern. There are two types. It could be either symmetrical or asymmetrical. What is the difference? Somebody would say. When your curve could be divided into two mirror images of each other, that is a symmetrical distribution. And so here we are looking at two halves that are equal. An asymmetrical distribution could look like this, or it could look like that. Now you clearly agree with me, when I divide this into two, this side here is not the same as that side. Also, when I divide this into two, this side is not the same as that side. So symmetrical distribution have mirror images of each other. This may not be the best symmetrical distribution there, but it's fairly symmetrical. Asymmetrical are not mirror images of each other. And so you will agree that if I divide this into two, this side is a bit bigger than that side. When one side is skewed, okay, this is called a left asymmetrical distribution. Now this one here is skewed toward the right side. The elongation, or what some people will call the tail, is on the right side. So this is a right skewed asymmetrical distribution. Now, for clarity's sake, I always use this example. Think about it as a dog. Where is the tail of the dog facing? If the tail is on this side, it's a right skew distribution. If the tail is on this side, it's a left skew distribution. So you look at this histogram here as an example, which is unimodal, but in terms of the pattern, in terms of the symmetry, it is skewed right. And so this is a right skewed asymmetrical distribution. Let's take a look at another example here, and I'm going to show you some examples. Again, I'm going to pause the video, and I want you to look at this and describe it in terms of the mode and the symmetry. How did it go? Great. So you could agree that here we have a single mode, okay, a single peak, and it is skewed right. So this is unimodal, and it's skewed up, not right, it's skewed left. So this is a left skewed unimodal distribution. Now, what do you think about panel B here? Yes, unimodal, right skewed. Now, what about panel C? You are right, it's also unimodal, but in terms of the pattern, it is symmetrical. And then let's take a look at the last one, which is super interesting. So we have a single peak, came down. There's a very small rise here. Somebody will say it's not a peak. It is a peak. So here we have one, then we have two. So far as you come down and then rise up again, irrespective of however high you rise, so far as it's a little higher than the one before, it is a peak. So this is a bimodal, and in terms of the symmetry or the pattern, it is right skewed. Good job. Okay, now the next thing I would like us to discuss, and I will bring this section to a close, I'm sorry, taking a bit longer, is the stem and leaf display. This is also another way to visualize the shape of our distribution for quantitative variables. And so we are also going to visualize the shape of the distribution, but we are looking at just quantitative data, quantitative variables. How do you create a stem and a leaf display? The algorithm is straightforward. First, divide your numbers into two parts. So basically, I'm just going to draw a straight line between two numbers. You write the stem to the left of the vertical column, And then to the right of the vertical column, we have the leaves. Let me give you a very simple example to illustrate this. Let's say I'm asking how many hours you studied in school for a specific week. Somebody did 5 hours. Somebody said, hey, I studied 14 hours. Somebody may have done 20 hours of study in a week. Somebody did 3 hours, 2 hours, maybe 12 hours. But let's work with these numbers. So how do I create a stem and leaf display for these numbers? We are looking at a quantitative variable, hours of study in a week. And these are the numbers recorded: 5, 14, 23, 2, and 12. Now, to create a stem and leaf display, I have to make sure that all the single-digit numbers have stems. And so what is the best way to turn a single-digit number into a double-digit number without changing the value of the number? What is the best way to turn a single-digit number into a double-digit number without changing the value of the number? And you are right. Just add a 0 in front of the number. And so if I put a 0 here, I'm turning the single-digit numbers into double-digit numbers, but I'm not changing the value of them. Now all my single-digit numbers are double-digit numbers. The next thing I'm going to do is I'm going to create a line to separate the two digits. On the left, I have my stems. On the right, I have my leaves. Now, the third and the last part is to create the stem and leaf display. So I'm going to create a table of this format. This side is where I have my stem. This side, I have my leaf. Now, think of a tree. Trees have single stems, okay? All trees have single stems, but multiple leaves. And so for each of these numbers, I'm going to keep a single stem, but I'm going to repeat the leaves. So the number 05, the 0 will be my stem, but the last digit to the right, which is the number 5, will become the leaf. And so here I have a stem of 0, a leaf of 5. And I have another stem of 0 here with a leaf of 3. I'm not going to repeat the stem. I'm just going to keep the stem of 0, but I'll repeat the leaf of 3. Here, 0, 2 will keep the stem of 0, repeat the leaf of 2, and that is it. Now let's go on to the next stem. The next value is 1 for the stem with a leaf of 4. And I have another 1 with a leaf of 2. Now the last one has the stem of 2 and the leaf of 0. Now let's try to see how this can help us visualize the shape of the variable or of the data or the distribution. So if I put everything in this format, over here I have the stem, and up here I have the leaf. First I have a stem of 0, and the leaves are 2. Okay, just writing them in ascending order, nothing too fancy. 2, 3, and 5. The next one has a stem of 1. The leaves are 2 and 4. The next one has a stem of 2, and the leaves just 0. Now I can draw a smooth curve over this like that. And now we can talk about the shape of the distribution. Quick question: what is the mode and what is the pattern? Right, the mode is unimodal and the pattern is asymmetrical, skewed. Again, look at the tail, skewed, right. Perfect. And so that is how we create a stem and leaf display. And this is how we represent it visually. Now let's go ahead and take a look at another example. In this example, we are looking at creating a stem and leaf display for female literacy in Islamic nations. We are only going to focus on the female aspect of our data here. And I want you to create a stem and leaf display for that. Now you will notice that this is the final work. So here we create a stem. Here we attach the leaves. And in this case, which is the third stage, we just rearrange the leaves in ascending order. So here's 1108. We rearrange them from the smallest value to the largest value. You don't have to do that. It doesn't make any difference if you don't do it, but that is another way to create a stem and leaf display. Okay, I'm gonna end here. No, maybe I should just pause. So I'm just gonna pause here. I want you to create a stem and leaf display for the male section. But take a look at something very important here. One, the values are 2-digit numbers, but Kazakhstan has 3-digit values. How are you gonna do that? I would strongly advise that 1 and 0 becomes your stem, and this 0 here becomes the leaf, just like you do over here. The 10 becomes the stem, the 0 becomes the leaf. Now, just to quickly run up here for stem and leaf display, we can also create something we call back-to-back stem and leaf display. For back-to-back stem and leaf display, what we do is, if you are comparing two categories, say male and female, we create a single stem, but we repeat the leaves. And then after that, you describe the distribution. Take a look at this. What can we say about the male distribution? Good. Unimodal, skewed left. For the females, what can we say about this? In terms of the mode, we have two peaks, bimodal, but in terms of the symmetry, it is skewed left. And then again, you can also perform what we call trimming in stems, that is cutting off some of the numbers. I don't really encourage that, but in stem and leaf display, you as a researcher can decide to trim, that is cut off some of the numbers and create your stem and leaf display for that. Now I'm going to end here at section 2.2. In our third video, we're going to look at what we call cross tabulation or two-way table data summarization. Thank you very much for joining me in this lecture video discussion. I will see you again in the next video.